So as Chris mentioned, going to be doing a session on Etherchannel today. So for Etherchannel, you might hear some other terminology when learning about Etherchannel. In fact, some common terms that basically mean the same thing. One example of that is Etherchannel being referred to as a port channel. So Etherchannel was a term developed by Cisco, and many people still call. Do you believe you can mute your mic, Chris?
Yeah, sorry, man.
Awesome, thank you. So Etherchannels, you might hear people still refer as a group of ports or group of links bundled together as an Etherchannel, but the industry standard name is port channel. So keep in mind whenever people mention both examples that they're basically talking about the same thing, just that Etherchannel is a Cisco proprietary term. So with Etherchannel, what we're doing with Etherchannel is we're taking, for example, just going to draw out a quick switch, just call this switch 1, and draw another switch, call this switch 2. What we're basically doing is logically, not physically, but logically bundling ports so that they appear as one. So before we configure an Etherchannel, in this diagram, there are 2 physical links and 2 logical links. But with Etherchannel, what we're able to do is combine the links logically. So there are still 2 physical links, but from Etherchannel's or from the device's actual perspective, it just becomes a 1 link. And does anyone here know why this might be important with spanning tree? Any takers for the question?
For convergence? Like make the
yes
yeah.
And no.
Okay.
You're kind of along the right path there. Give me one moment. So from spanning tree's perspective, let's just ignore the port channel right here. And let's just say switch 1 is our root bridge. What will spanning tree do since we have a physically looped topology? So let's say this is our designated ports, designated port, we've got an actual not designated port, we've got a root port right here. What do you think a spanning tree will do to this link right here?
It's gonna block it,
You're gonna block it.
You are correct. So even though we've got 2 different links, just gonna put be okay for block, we're still only able to use 1 link because we are running spanning tree. So spanning tree detects a physical loop, so it blocks 1 link to prevent a broadcast storm, for example, from happening. So even though we have 2 links, we're not able to fully utilize the throughput of both links. Now, if we were to combine both of these links logically, so with an Etherchannel, oops, redraw that real quick. Spanning tree would just see this as 1 link, logically. So we're, in essence, tricking spanning tree to make it seem, in this case with spanning tree, we're making it seem like we only have 1 link. In spanning tree's perspective, even though we have 2 separate links, but we logically bundle them. And spanning tree thinks that this is just one link. So in other words, they kind of like this. So from spanning tree's perspective, one have switch 2. Spanning tree would just think we just have one link. Make sense?
Yep.
Yes, it does.
Awesome. So that's one of the basic benefits that we have with spanning tree. Combining it with Etherchannel is we're not only able to use at a high level both of these links, but spanning tree thinks this is one link, so we'll just have a designated port here and a root port. So this is how spanning tree would think the links combined would look like. So we're not actually blocking any links anymore. Make sense?
Yes, it does.
Silence is yes.
Okay, I'll take that as a yes. So if we go on some interfaces, let's just say right here, we've got, I'm just gonna kind of redraw this. Got switch 1, you got switch 2. I'll show some hands-on examples soon enough. Say we got G00 right here, same right here, G01. Do you guys know what the general syntax is to create, to go on under the interface and create an Ether channel? So let's say we are in config-if. What command would we enter on the individual interface to form Ether channel link?
Channel group number mode on.
Yep, so channel-group.
Let's say 1.
Let's just use 1. So here's our number. We're actually and then mode. And Etherchannel has different modes, but for right now we're going to set up a static Etherchannel. I'll get into the basic dynamic Etherchannel protocols in a second. But we would type in channel-group, and we give it a number right here, mode, and then on. This number will correspond to a port channel interface that we create. So let's say, for example, we did channel-group 1 mode on. If we wanted to configure anything under the logical actual Ether channel or port channel, it would be interface port channel 1, for example. So when we do this, we are not only telling the interface that we want to put it in a Ether channel, but we're also going to create a logical interface. So in fact, let me go ahead, get my lab spun up so I can give some examples. So I'll actually bring this up. So this is what my topology actually looks like. I'll zoom in here. I'll move this up here. And do you guys see my secure CRT window?
Yeah, I see it.
Awesome. So let's say we want to configure a static Ether channel between switch 1, and we want to dump it into port channel 1 and switch 2. What would, if you guys are familiar, if you guys can guide me, what would be my configuration steps on switch 1?
Chris, thanks for volunteering. You got this.
Okay. you have to go in the interface G00.
All right.
And channel group.
Yes, sir. Channel group.
Let's say number 1 maybe. But
all right.
Does this number matter or not?
I'm sorry?
The number, does it matter or just a random one?
Yes.
It's yeah. So right now you're fine though.
Okay. And on.
So as I mentioned a bit before.
Yeah.
Yep. This right here, this number. Well, basically, when we run this command, we're not only telling it to join a port channel, but in this case, we're manually configuring a port channel with the number 1.
Okay. Okay, that makes sense.
Make sense?
Yes. Thank you.
All right. And what mode were we going to use?
On.
Yep. Yes, sir. So on. And see, right here we are creating for channel interface channel 1. And to go into our second interface.
And doing the same.
Mm-hmm.
You're doing the same?
So I'm just up arrowing and I'm going. Mm-hmm.
Okay.
So for these two interfaces, I'm going. Do you think you can? Oh, okay, there. Thank you. I'm telling both of these interfaces to join interface port channel 1. So this specifies what port channel I want to join the interfaces on. If I, for example, put channel-group 2, it would create a port channel number 2. But that's not what we want to do. We want to have them under both interfaces under port channel 1. Make sense? That's why we have the different number.
Yeah, I got it now. Thank you. But is that a problem if you have like the first interface in channel group 1 and the second one in channel group 2? Do those even really matter or?
Yes.
Yeah, okay.
In fact, let me run this verification command. I'll go ahead and show you. So one of the commands we can run to verify our Ether channel is show Ether channel summary. So when we create an Ether channel, we want to, and let's say we want to group the same ports to another side. This number is locally significant. So for example, on the other side, we can use group 2 and the Ether channel will come up. This is just for, I guess, for us to make it easier to maybe interpret. But it's important that if we're going to bundle these ports together on the other side as well, that we want to use the same Ether channel or actually port channel group number. Make sense?
Yes, thank you.
All right. And now let's do this on the other side. So once again, I would go into my interface that I want to create a bundle with. I can use interface range as well. So I can do G00 through 1. And I kill 2 birds with 1 stone. So I can just run channel-group. And just to show that I can use a different port channel interface number, I'll just use 2, just to demonstrate that my port channel will still come up. And then I will configure my mode. And right now we are configuring a static Ether channel with the mode on. So mode on references that we are creating a static Ether channel. And we can verify. We'll get some log messages right here, but we can run show ether channel summary, and we can see that our ports did come up. So here are some flags or codes that you want to maybe remember for the exam, but not just in general, also for the real world. So you don't always have to reference this. So right here, we have our group number. In this case, I specified group 1 when I did this command. Group 1. I specified, or actually, looking at this code right here, capital S, we can see right now that it's a layer 2 Ether channel interface. U means that we are up, so that is in use, which means that the port channel is up. And then on the port side, or actually before that, the protocol right here, if it shows a dash, that signifies that we are doing a static Ether channel, that we are not using a dynamic Ether channel protocol. So dash means that we are using on. And then we've got our ports. So right here, we've got our first port and our second port. And the code right here, P, represents bundled in port channel. So in fact, let's see. If I run spanning tree, we should see that we don't see interface G00 and G01. We just see our single port channel. So ignoring all these other interfaces right here, we just see that from spanning tree's perspective, do the same on the other side. Shows spanning tree. Same thing here, spanning tree just sees this as a single logical interface. And let me see, I think I got a message. Okay, never mind. We can see that if the more interfaces, or when we start bundling interfaces logically using an Ether channel, our port costs will begin to go down as well. So a normal gigabit interface will have a port cost of 4, but since we are bundling them, our port cost becomes lower, so it's a much more preferred port in spanning tree's perspective. Make sense?
Yes.
Awesome. So we've also got another command. So once again, what was the summary? What was the command we ran earlier to verify the Ether channel, Chris? You remember?
It was show your Ether channel.
Ether channel, and then
summary.
Yep.
Yeah.
So that's one of the verification commands we can use to check our port channel. We can also use show Ether channel. I would just use port channel. So this gives us a lot more detailed output than show Ether channel summary up here. So this was show Ether channel. Show Ether channel summary. And show Ether channel port channel gives us more specific information. So it tells us we are group 2. And we've got our different interfaces. We are in Ether channel state of on. Our protocol is a dash, which means we are using static Ether channel, or we configure channel dash group. In this case, 2 mode on. This is in use. We've got 2 ports. And we've got some other information, like right here, time since last port channel bundled. Right here, and our last bundled interface. Make sense?
Yes, it does.
Awesome. So one thing with Ether channels is that we have to have some specific parameters that have to match, such as speed, for example, duplex, and I'll explain more on those in a bit. So for example, speed, duplex, our link must be, for example, a trunk or an access port on both sides. So these parameters must have to match. If not, we will have problems with the Ether channel coming up, for example. So in order to somewhat remediate this, we would use a dynamic Ether channel protocol to basically kind of discover and see if our parameters match on both sides. So with static mode on, in most cases, if, for example, you configured on this side, let's just say G00 as an access port instead of a trunk. Let's just say all of these interfaces were supposed to be trunks. There will be issues with forwarding of traffic. And mode on or static mode of Ether channel will not detect that by default. So we will have problems forwarding packets and frames. So that's why we have dynamic Ether channel protocol. So I'll load up my kind of whiteboard here. And we've got two different types. So does anyone know the two different types of dynamic Ether channel protocols by any chance?
LAGP and LACP?
Yep, so we've got LACP, and we've got PA little g P. So it's written a bit weird. LACP is an industry standard Ether channel protocol or port channeling protocol. Give me one moment. And it is also referred to as industry standard. It is also referred to as in the IEEE as 802.3 AD. That's the actual standard name. We can have up to 16 interfaces, so I'll actually erase this and get back to PAGP. We can have up to 16 interfaces in Ether channel, in an Ether channel, but only 8 can be active. Meaning that you might have 16 links in total, but only 8 of those will be active as ones. Other ones will just kind of be in standby in case one of the links fails. And your switch would switch over to using that link if you have more than 8 active interfaces or links with Ether channel. And we've got 2 different actual modes. Does anyone know the modes? With LACP?
I believe for this one it's active and passive.
Correct.
Yeah.
So we have active and passive mode. Active mode actively, as the name suggests, tries to negotiate an Ether channel. So let's just say right here we've got a switch 1, we've got the switch 2, we've got 2 different links right here. Active will actively try to send packets to bring up an Ether channel. And passive will form an Ether channel, but only if it receives a packet. So in order to form an Ether channel with these 2 different modes, these are our 2 different, we've got several combinations. So active /active will form an ether channel. Active/passive will form an ether channel as well. But passive mode and passive, again, looks good enough. These will not form ether channels. Because if both, think about this like, are you guys familiar with, for example, Chris, are you familiar with DTP?
Yes, a little bit.
Yeah, so one thing you probably remember and understand is DTP is completely separate, but you can make an analogy with DTP that whenever you have one side as desirable and one side as auto, or both sides as desirable, a trunk link will come up, right? But if you have both as auto, the links won't come up, right? Or sorry, yeah.
Yeah, you're right.
So similarly here, you can think about it in that way, where you need, you can have two negotiating or at least one negotiating. If you have no one negotiating, our ether channel will not come up. A command to get LACP going, so the industry standard ether channel dynamic protocol or negotiation protocol, we would use channel dash group, our group number, mode, and then we use, I believe Cisco Press likes to use these types of symbols, or actually brackets, either active or passive on an interface. So we would be under, for example, config if, and we would go under the interface and use this command. Make sense?
Yes, so basically the passive link become active if the active link fail, right?
So you're saying what you're saying is that a passive link or a passive mode will switch over to active?
Yeah, always stay passive whatever happened.
In this case, it's just whatever you set it to. So if you set one side to passive, it will always stay passive. If you set one side to active, the modes don't change, but depending on how you have your combination, a link will come up. So for example, on this side, we can have active and passive, if I can spell correctly, passive, and same on this side, active, passive, and our ether channel will come up. That's supposed to be a check mark. So, make sense?
Yes, but if for example, the top link fail, what's happened to the mode? Is stay active and passive?
If the top link fails, for example, the bottom link would still stay active and passive. Nothing's going to change. It's just that in this case, since our link did come up, our ether channel link, we would just have one interface in the ether channel. But we can add more in the future.
Okay, thank you.
No problem. So let's actually go ahead and see that in action. Let me move my iPad to the right over here. Kind of minimize this, move it over. And do you guys see my secure CRT window?
Yes.
All right. So I'm just gonna erase I'm gonna go back to the default configuration for both my interfaces so I can kind of start from the beginning. I will paste this on both sides. So you can see here my port channel will begin to go down. Let me move back to this side, so switch 1. Let me see if I still have my port channel interface. So do show IP interface brief. So even if, for example, you remove, so let's just do a do show run interface G00. Even though we removed our Etherchannel configuration mode, our port channel will still, our logical port channel interface will still exist. So if you want to remove the port channel completely, you can do a no interface port channel 1, in this case. So that's to fully erase the port channel configuration. And once again, on this side, we use port channel number 2. So I will remove this port channel interface. So no interface port channel 2. We should see that it has gone down. So I'm going to go into an interface range, and I'm going to configure LACP or LACP, some people would prefer to call it. And can you kind of guide me with this configuration, Chris?
Okay, so channel group again?
So channel group.
1.
All right.
And which link are we?
I used an interface range right here.
Okay, both.
For
All right.
Both of these links.
Okay. So active.
All right. Active. And we can see that our line protocol here is bouncing. And now let's do that on the other side. So I'm going to do an interface range G00-1. So we basically configure both interfaces at the same time. And can you guide me through this again?
Channel group.
Yes, sir. Channel group.
Number 2.
All right. So let's just use number 2 in this case, mode.
Yeah, mode. And passive this time?
Sure. Let's do passive. So once again, I haven't gotten to the desire one and auto, but right now we're just using the LACP command, so active and passive. So on this side, right here, I configured active mode, and right here, I'm going to configure passive. And our interfaces will bounce, so they will go down and then they will come up. So right now I am getting LACP not enabled on the remote port. Actually, right, hopefully in this version there have been, okay, good. So yeah, I was worried that in this version of the CML images, there have been some bugs with Etherchannel before where it didn't come up, but in this case it did. Anyway, so what command would we use to verify our Etherchannel, Chris? The first command I used.
Show interchannel summary, right?
Yes, sir. Yeah. So once again, I can see based on my status codes that I am using a layer 2 Etherchannel. Once again, S means layer 2. U means that it is in use. In other words, it's up. Our protocol of choice is LACP. And we've got 2 different interfaces. Once again, P meaning they are bundled in a port channel. And let's do this on the other side. So we'll show Etherchannel summary. And we see the same type of output. So in this case, we just decided to use Etherchannel port channel interface number 2. So it doesn't have to match on both sides. It's just something that you can either match or not have match on either side. Make sense?
Yes, so basically it can match if we want one on both switches.
So it's optional. We can use the same group number, but if we want to, we can use different group numbers. So in this case, that's why my first example was one. This one, we just used 2 different group numbers just to show that it does not have to match for the Ether channel to come up. So now let's expand this information a bit and find out more about the port channel. So I'm going to do show Ether channel. And do you remember what command I used earlier, Chris?
Maybe no, I don't remember. Port channel?
Okay. Yes, sir. So port channel. So this once again gives us a lot more detailed information about our port channel. So primary aggregator, let me run this on the other side. So show Ether channel, port dash channel. Right here, we've got our age of our Ether channel. So it's in 4 minutes and 5 seconds. We've got 2 ports once again. Our port state is in use. We are using LACP. And once again, it lists what ports we have. And our last bundled port. And this is the last, how long ago that port was added to the bundle. Same on this side.
I have a quick question.
Sure.
Can we have on one switch active and passive mode?
Yes, that's exactly what we did here. Or, I'm sorry, on one switch you said?
Yeah, on the, for example, here G00 active and G01 passive. Can we have that?
That, no, we cannot. So that must be, checking my notes right here.
So, okay, so
what was the question?
So his question.
Go ahead.
Go ahead.
Okay, my question is on this, for example, switch 1, can we have on G00 active and G01 passive? Can we have both mode on the same switch? Active and passive on the same switch? If that makes sense.
I don't believe so. I think it's tied more to where the Ether channel is in memory. That'd be something to butts with and see what happens.
Maybe you can have passive on, for example, active on switch 1 G00 and passive on switch 2 G00.
You can do that.
Yes, that's, for example, what we did here.
Passive here, and change, if you switch here to G01 to passive, and on the switch 2 active, G01 active. Maybe you can do that.
I think it'll scream at you. I don't remember exactly, to be honest. Let's find out, Michael.
Yeah, let's find out.
Do it.
Right, so channel group. We are using 1 on this side. Mode, let's switch this to passive.
Oh, it took it.
It's changing state to down. So let's, oops.
So,
And did not enable on the remote board.
So here you have to configure the G01 to active.
Yep. So let me just trying to hit Control-Shift-6 to Accidentally typed in two together. I should have turned on. Let me do this on this side. IP
That's
domain.
my favorite typo to make.
Yeah, it is. And the virtual devices do not like Control-Shift-6.
No.
There we go. All right. So you said
interface G01 on the switch 2. Channel group 2 mode active. Yeah.
Let's go ahead and see.
So far looks good. Did it? This page is
still up?
Isn't that? No, S is for switching.
Yes, means layer 2.
Yeah, I think the little s is suspended.
Yep. So little s would be suspended. Big S.
Yeah, it looks like you work. What about show Etherchannel port channel?
This one?
Yeah. Yeah, sorry.
Yeah, let's.
Okay. And let's run it on this side as well. So show Etherchannel. Port channel. So we can see that it did come up.
So it looks like you can have this configuration, but you should switch the same on the second switch, basically.
Yeah, it's best practice not to make things confusing.
Yeah.
On one switch for one Etherchannel bundle to have both active, for example, and on the other side have both passive or both active.
Yeah.
Just so it's easier to understand.
On the same link, you can have active, passive. So between switches, I mean, on the segment, you should have active and passive on both sides, not active and active, or passive.
Well,
you can
learn something new.
Same here, but
what is this? That last port unbundled.
Oh, that was last port unbundled.
But it's not unbundled because it's still.
Yeah, so I guess it designated it as unbundled, but then we bundled it back in. So last bundled. Oh, so this one was the last one that we modified. And this could change.
Yeah,
but in this case, we were just messing with 0-1.
Yeah,
that makes sense.
So on both sides, you can have active, Chris. So active on one side and active on the other. Or you can do active and passive. Make sense?
Yes, thank you.
All right. Let me looking at my notes here. So, all right. So let me bring up my tablet once again. And now I will go on to PAGP. So PAGP, I'll draw it out here, is a Cisco proprietary. So it's Cisco proprietary Etherchannel negotiation protocol or Etherchannel dynamic protocol, depending on how you see it in some documentation. So it's Cisco proprietary, meaning that to use this Etherchannel protocol, you must have both Cisco switches. So for example, you can't have one Cisco switch and one Juniper switch running PAGP. You would only be able to do it on two different switches. On two of the same type of switch, or not type of switch, but it's from the same vendor. that being Cisco in this case, because it's Cisco proprietary. And this actually came out before LACP did. So Cisco actually was the one that came up with Etherchannel. I believe the original implementation was called Fast Etherchannel, as it was meant for fast Ethernet interfaces. But with PAGP, instead of active and passive, we are using desirable and auto modes. So instead of active and passive, the equivalent in PAGP would be desirable and auto. Very similar to like in DTP. So
But the meaning is the same, right?
Did you want to say something, Chris?
The meaning is the same, right?
I'm sorry?
I asked.
Correct.
Yeah, okay.
So desirable will have, let me move this to the right or left. We'll have an port channel interface come up. Desirable and auto as well will have an Etherchannel bundle come up. But auto and auto will not. So you need at least, for example, in this case, you need at least one side, you could say desirably negotiating the Etherchannel link. So if you have, for example, two that are just auto, they will not bring up the Etherchannel. Make sense?
Yes.
Awesome. One more thing is that with PAGP, your max number of interfaces you can bundle for a bundle is eight interfaces. And let's actually go ahead and configure that. So I will minimize this once again. And I'm just going to basically go to my default configuration of my interfaces. I'm just going to 0-1. And that will remove my Etherchannel config from the interfaces. Go ahead and paste this in. And once again, even though you do remove the Etherchannel configuration, your port channel will still be your actual logical port channel interface will still exist. So to remove it, you would just do no interface, port channel, and then your number. And on this side, it's port channel 2, so I'm just going to type in no interface P2. All right, so do you want to help me once again and guide me through this configuration, Chris?
Let's do it. So
awesome.
You in the interface? No, okay.
Did you want to do interface range or
yeah,
interface by interface?
No, range is good.
All right.
So channel group 1.
Channel group. Choose one.
Yeah, mode desirable.
All right, let's use desirable. So right here also in the context sensitive help tells you basically what we're dealing with. So desirable and auto are PAGP, and active and passive are LACP, in case you forget. So once again on this side, what would I configure, Chris?
Channel group number 2.
All right.
Mode auto.
Auto. So it's going to bundle these links and also create our logical port channel 2 interface. So it's going to change state. All right, and we can see our line protocol for interface port channel 1 has changed up, and port channel 2 has changed state up. So what was one of the first verification commands I ran to check my bundle?
It was a show Etherchannel summary.
Correct. So very similar output, very similar codes. S, capital S, layer 2, capital U, meaning it is in use or up, in other words. And then P on the actual interfaces, meaning they are bundled. And we are using PAGP. And let's run that on the other side to show Etherchannel summary. Once again, it should be the exact same output. And to further find out more information about our Ether channels, you can do port channel. So it's once again in use. Our age of our port channel is about 2 minutes and 23 seconds. And our Ether channel state right here tells us we are using desirable on both ports. Let's do the same on the other side. So show Ether channel, port channel. And right here we have auto mode. Let's just go into this output. It says it's automatic. But that shows us our output.
What the SL mean after automatic? What is the, yeah. This.
That's a good question. So actually, let me look that up. I never actually looked into what SL means. Let me see.
I think it's a I actually, it's not a L. I'm looking too, and it's a SI. I'm looking on Google too, and this is what they say.
What does it say?
Yeah, but I don't know what that means.
All right, let me go ahead and look that up real quick. So I believe S meaning the switching timer is running and the interface timer is running. Is that the same thing you got?
Yeah, I think it's that.
So that just basically means that it's basically running some keep alives between the ports to make sure that the ports are not only active, but that they still maintain the same configuration. Otherwise, if there's a difference of configuration, the ports will go into error disable mode. Make sense?
Yes, thank you.
No problem. So I'll bring back up my... Anybody have any other questions about what I'm doing right now? Or about Ether channels in general? I will take that as a no. Of course, if you have any questions, feel free to also text in the CCNA chat. So these are some parameters that must match between interfaces and links in an Ether channel. So we must have the same speed. So for example, one side cannot be set to gigabit and the other side be set to fast Ethernet. They must have the same speed. If not, the Ether channel is going to go down, and our interfaces that were associated with that Ether channel will go into error disabled mode. Our duplex must be the same. So once again, cannot have one side full duplex and the other not. Generally speaking, with most modern equipment, you'll be in full duplex mode. But who knows, they might throw that in an exam or something. Cisco might and say, hey, what happens if one side is full duplex and the other is half duplex? So we have to agree to, on both sides, if it's going to be an access port or trunk. So we cannot have one switch with one link set as a trunk interface and on the other side. So for example, let's draw switch 1, switch 2. Just give it some links. Let's just say we have both links in the same Ether channel. We cannot say, for example, we'll say this link as a trunk, and this link right here is an access, or well, actually the individual ports, right? Otherwise, the Ether channel will go down and our ports will go into error disabled. So if we're going to basically make an Ether channel, we must agree that both links, or however many links, will be either trunk, so a trunk link, or access. It cannot be one or the other. That has to match. And if we are using, for example, a trunk, so let's say we are using a trunk link, our allowed VLANs must match on the same time, same side. So once again, we have switch 1, and we have switch 2. Switch 2, not switch 1. And we have some links. And let's just say, for example, on one side, so let's just say right here on switch 1 side, we are allowing 10, 20, 30. And right here on switch 2's side, on the interfaces, or actually the port channel interface, we are allowing only 10 and 20. Even though we might not be using those certain VLANs, there is a VLAN list mismatch. So if, for example, we have this scenario, our trunk will not form and our interfaces will once again go into Ether channel. So something common is that if we have problems on either side, our interfaces involved in those port channels or Ether channels will go into the error disabled state. And once again, with the trunk, we must match native VLAN. And of course, this is a best practice. Otherwise, we might have certain traffic going from one VLAN to the other, or certain traffic being untagged. And regardless, even if you did have a mismatch of native VLAN and you were using Ether channel or not, CDP is going to definitely scream at you, tell you native VLAN mismatch. So this should be a given. And our Stp port settings. Meaning, for example, just redraw. That looks kind of ugly. Switch 1 and switch 2. Let's just say our port costs for these links are 4 and 4. And we manually set the port costs on this side to 3 and 3, for example. Our Ether channel will not come up. So, for example, our port costs must match in Etherchannel in order for the Etherchannel to come up. So once again, speed, duplex, what type of interface are we going to use? Are we going to use an access port? If so, our access VLAN must match. Are we going to use a trunk? If we're going to use a trunk, well, our allowed VLAN list must match, and our native VLAN must match on both sides. And regardless if we're using an access port or a trunk port, our Stp port settings must match. So for example, in this case, our cost must match. Otherwise, our Etherchannel will not come up. Make sense?
Yes, it's perfect.
Awesome. And keep in mind, I have seen in some cases where I have seen in some cases where a switch is running a Etherchannel negotiation protocol like LACP or PAGP. And even though there might be some mismatch, the Etherchannel might still be up. So it's one of those things that can fail, but we use those protocols just in case to keep ourselves covered in case we might have fat fingered something like an allowed VLAN list or something. So just know that they can fail, but it's just there just in case to kind of keep us safe. Make sense?
Okay, thank you.
All right. And now to move on to some other Etherchannel. Did you want to say something, Chris?
No, sorry, it's my computer is a little bit slow.
Oh, no worries, man. No worries whatsoever. So when we use Etherchannels, they use a form of load balancing. So even though in theory, we're able to use multiple links for basically load balancing traffic, in reality, there is an actual calculation that goes on in the back end with actually choosing what link we will use for a specific type of traffic. And we use certain parameters. So depending on the switch, you want to check what type of load balancing method we're using. So it's not, well, I mean, I don't know if current books cover it, but something like in PPP, the point-to-point protocol, just as an example, our actual packets would actually logically get sliced and be sent out all ports, so all available ports in the bundle. So that would be true form of actual load balancing. But in here, what we're actually doing is we're running a calculation because this is a limitation of the ASICs for the switch interfaces, so the application-specific integrated circuits. So to see what type of load balancing we are using, I would run this command, show Etherchannel load balance. And this might change depending on switch to switch. You can always change this. But here, we are currently load balancing. We are running an XOR calculation based on our source and destination IP. So the switch is basically running a calculation, and it kind of combines both the source and destination IP. It runs an XOR calculation, and based on what number that interface has designated to it, it will use that interface. So it might give an output of 0 or 1, 2, 3, 4, 5, 6, 7. And for example, let's just say, did anyone have a question? Guess not. So let's just say, for example, our top interface has, let's just say a value of 1, and our bottom interface in the actual port channel has a value of 2. and we basically come across a packet and we get a value of 1, it will only be actually sent through this interface. So what I'm basically trying to say here is that just because we have multiple links bundled doesn't mean we're actually going to go, for example, in this case, 50% traffic on each link. It just honestly depends on how the calculation is run. So you might have a case where we might have 10 gig worth of traffic trying to escape this link, but just because the way the calculation is run, G0/1 might not even be touched at all. Make sense? Yeah.
You didn't change that, did you? Like that's how it came up on your switch when you configured this?
That's, yes, how it came up on my switch. This will vary from switch to switch.
Okay.
Yeah, go ahead.
Before, Cisco documentation was saying it's based on the source MAC address. If they've started changing it based on platform, that would be a good thing to know.
Yes, that's, I might have said that if I'm not wrong, but it will switch on platform to platform. So that's one thing I will emphasize is on these virtual switches and my CML images, it shows source and destination IP. And for example, I'll just pull up the book through Safari Books, kind of what I use to make the lesson plan off of, because I know a lot of people that are studying for a CCNA here use this book. So for example, here, our load balancing protocol is our source MAC. We are running an XOR operation based on our source MAC. So that will vary from platform to platform.
Okay. Just like, because when you said, I was like, did I miss something?
No, you're good. You're good. It just will vary from platform to platform. In fact, to change this, I would go into global config mode to change my load balancing method. I just pasted this command in. Port channel, if I can spell correctly, load balance. We have different options. We can load balance based on our destination IP, destination MAC, source and destination IP, source and destination MAC, source IP, and source MAC. And some platforms you might be able to load balance on source and destination port number and IP. So you're able to get a lot more fancy with your load balancing. So once again, it just varies from platform to platform. And in this case, you have source and destination IP. So does that answer your question, Spencer?
Oh, yeah. It's been a minute since I went over load balancing, so I just didn't want to think I missed something. But like you said, it might just be based on the new products you're using, such as like CSRs or whatever model of switch that you've got on CML here or Eve.
Yeah, here it's just normal iOS. This isn't iOS XE. This is 15.2. So normal iOS 15.2.
Interesting. Yeah, that's a weird one.
Yeah, so that's something you will want to keep in mind. So once again, on this side, I'll load that. And it says I'm using source and destination IP. And basically we can basically tells us I used per protocol. So if we have non-IP traffic, we will use source and destination MAC address. But if we have IPv4, source and destination IP address, IPv4 address, and for IPv6, it's source and destination IPv6 address. And once again, it uses the XOR operation, and it focuses on the low order bits of, in this case, an IP address. If you had it as a MAC address, your load balancing methodology, you would use your MAC address low order bits. And I'll pull this up real quick and mention that with Etherchannel, it might not be part of your CCNA exam, but it's best to create ether channels with interfaces that have a power of 2, meaning for the ether channel load balancing protocol to work best, we would want to use actually 2 interfaces, 4 interfaces, or 8 interfaces for it to work the most efficiently for the load balancing using the XOR Boolean logic. And we can actually, let's just say we were curious, we can actually go ahead and see based on this load balancing method. Let's just say we have, we can test the ether channel. I believe this command will work on CML images. So we can do a test, ether. I guess on here we cannot, because this is a virtual device. So we're trying to virtualize ASICs. But if you had a physical switch, it's right here in this section, you can actually test the load balancing of our interface and our port channel, as well as, in this case, since we're using source MAC address, our source MAC address going to our destination MAC address. And it would give us an output of, okay, this would select based on whatever window Odom was using. It would select G1022 of port channel 1. And if we choose, for example, a different destination, it would still use port channel 1. And you can kind of play around with this and see how traffic from our source to our destination would load balance across like a specific port. And I believe that's all I have for today, unless you guys have any other questions about ether channels.
Did you go over some of the troubleshooting steps that you can take with when they're misconfigured or you got some errors?
Sure, let's break stuff.
Like, yeah, there's a few things you want to watch out for if you're not careful with how you're plugging in the actual physical cabling. That can actually disrupt your ether channel. So I think Mr. Hilton is going to go over that.
Yeah, I can go over that. So, for example, let's start off with, let's change the speed on one side. So on switch 2, I will go into my individual interface G00. And let's just say I want to change the speed. Can I do that here? To 100 megabits per second. Oh yeah, I believe I cannot with...
what about the bandwidth command?
Bandwidth is logical. Bandwidth. So with the bandwidth command, that only really affects QoS settings and routing protocol settings. That does not actually...
Like a 100 megabit port instead of a gigabit port.
Correct.
Okay.
So there's some limitations with some virtual stuff, as you can see. So let's say we wanted to put this in half duplex. We cannot. And I remember, even if I turn off auto negotiation, I can't really do that. Let's do something else. So let's check the running configuration of G00. And let's just say switch port access Vlan 5. So we're going to dump it into Vlan 5. And we will see G00 is not compatible, will be suspended because our access VLAN of our side is 5 and G01 is 1. So let's see what happens. So do show ether channel summary. And little s, not big S, little s, we can see in our code right here means it is suspended. So if I do a do show interface status error disabled, show, let's see, show interface status, it will be in suspended mode, which is equivalent of us being in error disabled mode. And once again, we can see that, that it is suspended. We can check the other side as well. So show ether channel summary. And on this side, it is I, which means it is independent. Let me look for the actual code here, or standalone. That's the way I remember I means independent, or actually means that it's standalone, meaning that it's in the ether channel, but it's not actually being bundled. Because, for example, on this side, we changed our access VLAN to 5 instead of 1. So let me go ahead and fix that. So switch port access VLAN 1. And actually, in this case, it did fix it, but I've seen in some cases where it will straight up put you in error disable mode to prevent some type of forwarding problem. So it's just kind of acting a bit strange because we are in a virtual environment. But just keep in mind that we would have to go in under the interface and type in shut and no shut on the actual Cisco device. And let's say, yeah.
Nope. Keep going. Sorry.
All right. So let's actually check this side. So show ether channel summary. All right. Yep. And it's bundled. So let's just say on one side, I go under an interface and I want to set it as a trunk accidentally. So switch port trunk and cap. .1Q, switch port mode trunk. And once again, it'll tell us it is not compatible. Let me check something real quick. Do show ether channel.
Suspended.
See, it is suspended. Do show ether channel summary. So our port is suspended. Make sense?
So here it's suspended in the both devices, right? With the trunking mismatch problem.
Correct.
Okay. So it's not independent this time. Okay.
Nope. So do show, let's see, do show interface. It is suspended.
Okay.
All right, so I guess in this case, it came up once I took away those commands.
But in a real world, you have to shut down, no shutdown, right?
Correct. So this would be a lot better demonstrated if I were on a physical switch.
Yeah.
But I would have to, if I ran this command, show interface status, it would show me the status would actually be error disabled.
Okay.
So we covered the trunk. And let's say I want to set both sides to a trunk. So this is one thing that I forgot to mention. If you want to configure however many devices are in the ether channel just once, besides doing the interface range, you can, let me just check whether it's up. Yep, you can go into the ether channel interface. So interface port channel. See, exit. Interface with default command. Port dash channel 1. And I can do, for example, on this side, switch port trunk encapsulation.1q and switch port mode trunk. And let me match that up on this side. So interface port dash channel 2, switch port trunk encapsulation.1q, switch port mode trunk. Show ether channel summary. Here we are still up. If I do a do show run interface G00, we can see that because we configured this directly on our port channel, it automatically passed down to our port channel interface members. So this was not there before.
And if you disable the switch port trunk, can you disable the trunk mode on the interface, even if you configure it in the port channels interface?
Yep, sense? we can override that, and overriding that will of course cause it to go down, but let's just say switch port mode trunk on this interface. This should so let me do this to show interface trunk. And no, do show run interface G00. Let me also take off the other command. So no switch port trunk encapsulation dot 1q. And see, even though we decided to override that on our own, it's not compatible and will be suspended.
Okay. Okay, thank you.
Sound good?
Yeah, perfect.
All right, so let's go ahead and put that back in. So switch port trunk encap.1q, switch port mode trunk. We're setting it back to a trunk. And let's just say on this side, let me go back, make sure I'm back in port channel 1. And let's just say I decided to change the native VLAN. So switch port trunk native VLAN. And let's just say instead of having 1, since 1 is the default out of the box, let's just say it's 10. Actually, let me go ahead and create 10 first. VLAN 10 exit, interface P, let me do show VLAN brief. So besides spanning tree complaining, do show interface, do show run interface P1 for channel 1. All right, so it did take it. So let's do show. So it should bring it down, but right here. Yep. Wait, no. CDP is complaining, but it actually should bring the Ether channel down. So in this case, so kind of what I said before, there are some times where I guess for the negotiation protocols, they might not work correctly, especially since we're on virtual. In this case, it's not working correctly in the way that it should actually put the ports in air disabled. But in this case, it's not. But it might be the other way around in the actual real world deployment with the switch. But actually, I'll match it up on the other side just so it stops complaining. So switch port trunk, native VLAN 10. VLAN 10. It should take that. So create VLAN 10 do show run interface P2. Interface P2. Switch port trunk native VLAN 10. For trunk. Yep. It should.
Yeah.
Well, I guess in this case it did complain, but then it brought itself up. So this type of troubleshooting is best to have like on an actual physical switch, just so you can actually see what would actually happen. In this case, I'm running into some limitations of the virtual environment. But just know that it's always best practice to match things up on both sides anyway, regardless. So you always want to make sure to match speed, duplex, whether we're using access port, once again, or a trunk. If we're using a trunk, we want to match the native VLAN and our Stp port settings. So actually, show Etherchannel summary. All right, so it's up. So let's say I want to configure the port cost, spanning tree cost from, let's look at what it's right now. Do show spanning tree. Right now, our port channel is set to 3. So let's say we want to switch it from 3 to 2 on one side. Spanning dash tree cost, change the cost. So in this case, it's not affecting anything, but just know that you do want to match your Stp port settings on both sides. Make sense?
Yes, sounds good.
All right. And I guess that's all for my session today. Do you guys have any other questions, comments, concerns, anything?
Just another one. If you're ever dealing with these, like in a data center, so it's really fun to see these when like the link is like 3 inches long. But in a data center, these could be anywhere from 200 to 300 feet or longer if over fiber. So it's very important to understand how these cables are going across your actual physical layout, because I've seen this about 3 or 4 times where they'll get them mixed up and they'll plug the cable into like 2 other devices, in which case one of those will not work, and then they'll spend a lot of time trying to troubleshoot why is my port suspended.
Yep, so the physical cabling is important as well.
That's probably going to be 90% of your problems with these things, to be honest. The other 5% or 8% will be configuration errors, and the other 2% will be like the random tidbits that you'll probably forget after the exam and have to look up in documentation.